Okay.
I
If
forgot.
you are watching this video, then you are hopefully intending to learn a little bit more about the crash data analysis tool and the import tool functionality. And we're going to do a little bit of a test drive here with Eric Green. So, Eric, if you want to maybe just help us navigate through the basic process, we'll get started.
Absolutely. I would highly recommend watching the query tool tutorial before this one, as we go into some details that kind of carry over into this tool, but they're done more automatically, as the import tool does not get as much info from the user as the query tool. So as you likely are aware, we have the two options on the homepage: query tool, import tool. Um, Ultimately, we should have an option for intersection analysis as well, and that should that will also be built into the import tool, so you can import a list of intersections as well. But if you find yourself with a list of roadway segments, more than one, basically. If you have one segment you want to look at, use the query tool. If you have more than one segment, in fact, several, dozens or hundreds, and you have them stored in a CSV file, uh, and it indicates the RT unique, which is the county and the route, and the beginning and ending mile points of the segments, you can use the import tool to do analysis in a batch format. So the same analysis will be performed on every row in the CSV file, and it'll produce a result that you can use to sort, filter, or prioritize your segments.
Would you say that with the import tool, given the batch nature, that it's maybe less thorough, less comprehensive?
Yes, definitely. We don't get as much feedback from the user using the import tool. We're having to make assumptions based on the data, and there isn't that iterative process that we talked about in the query tool, where you're able to go back through and change the segmentation. So I would only use the import tool if you're confident that your segments are homogeneous and consistent in terms of roadway segments. You can use the import tool as a way to test to see how homogeneous your segments are, because the import tool will report that segment score. So if you've watched the query tool, you know that there's a score between 0 and 100% associated with each segment. And if you get a really low segment score, you want to go back and kind of change up the segmentation. So the import tool can be used as a way to kind of screen for that.
You mentioned during the query tool that you view this process as linear, giving the user opportunity to really think about the direction they want the analysis to go. Could you see a typical use case flipping back and forth between the tools to sort of hone in on how that analysis should go before they finally land on one particular pathway to generate a report?
Yeah, I could see using the query tool as a way to get familiar with where you should start and end segments, and what features really matter in terms of homogeneous segments. And it may be totally different for rural two-way, two-lane roads, rural two-lane roads versus multi-lane divided facilities. And once you kind of get a good feel for that, you can probably move over to the import tool and and use it in a more automated fashion. And then kind of switching back and forth. If you have a low score on the a low segment score, you can use the query tool again to figure out what's going on, and then kind of report back to the import tool.
Great. Well,
Uh,
let's jump in.
all right, so I'm going to click the import tool. And remember, you'll have to be logged in with either basic or advanced um, roles associated with your account. And if someone does have an account and they haven't been assigned a role yet, they'll get a message on the screen saying such. You'll just want to contact one of the CDAD administrators and request access. And we validate all requests with the Transportation Cabinet to ensure that the folks asking for a request have a signed MOU on file. So that's something you want to make sure you have before making the request. So the import tool should look pretty similar to the query tool, in that you're allowed to define your crash types, pick from different road types, and then filter by the 5 years available. What you'll see that is missing is the first step in the query tool was county, route, and mile point range. We don't have that here because all of that is going to be submitted by an input file, a file that you'll import in. So in order to run this analysis, you're going to have a CSV file that contains the start and ending mile points of all your segments for analysis. Again, this is for roadway segments at this point, not really set up for intersections, but during that next release in the next fiscal year, we'll have an option here where you can import intersections as well. Step 2 for this really focuses on whether or not you just want crashes or if you want to calculate EECs. Now, if you just want crash data, it's pretty straightforward. This box is checked by default and you can't uncheck it. For the import tool to do anything, it needs to match it to crash data. You'll import in, you'll load a CSV file that contains, at a minimum, a route, a beginning, and an ending mile point. By default, we're looking for these 3 field names, but you can use the variations on the list below based on the files that you might be used to using. But you'll definitely want to get 3 fields that match any one of these criteria. By default, the tool will just take all the segments row by row and count up the number of crashes in each segment. Now, if you'll notice, severity isn't shown here, and that's because we're going to go ahead and give you all of the data for K, A, B, C, and O. The reason we're doing that is you can combine those in any manner you want, just with a quick summation in Excel, and make your own categories for analysis on your own, and that's pretty straightforward. So if you have a route between mile marker 1 and 2 and you upload it into this form, it will count the number of Cabco crashes among all the Cabco categories separately and attach them to the database. So I'm going to show you just the simple version of this right now, and I am going to go to a test CSV that we have here that just has a handful of segments plugged in. When we're ready there, I'm going to go ahead and get crashes.
So I guess it's worth underscoring at this point, in case people haven't picked up already, it has to be a CSV file. It can't be an Excel file. It can't be some other, Google Doc or something like that. It has to be this one particular file format. So Correct. They need to do a little bit of data processing before they can use this tool.
Yeah, and that's basically because we're using comma-separated values as a means to parsing out the data. In the future, we may support other data types, but yeah, for now, I think just simply creating a CSV, which you can do in Excel, easy enough. In fact, here is the results table, which shows the RT unique, the beginning mile point, and the ending mile point. Since this is just a test file, I love to pick on Kentucky 55 in Adair County. Alphabetically, it's the first route that shows up in our database, and it's the default route when you run the tool in the query tool. So it's an easy segment to kind of look at. So here I just put in between 0 and 1, between 0 and 2, 0, 3, and 0, 5 for Kentucky 55. And you'll see here that we have two O crashes, 5, and then 8. So it's just finding O crashes in those segments. But then I went ahead and threw in a US 27 from 0 to 3, If you saw the import or the query tool demo, you may have noticed we use this as an example for our segmentation experience. And here it's showing no fatalities, luckily, but then 5 A's, 45 B's, 95 C's, and over 1,000 O's. So that is a segment that's there in the southern part of Nicholsville Road in Fayette County, approaching the mall. And so as you see, whatever fields you have in the CSV, it will just tack on a K, A, B, C, and O. Again, we're applying U's and H crashes into the O category. I didn't make an option to remove those because, again, this isn't really as finely detailed as the query tool. If you're really getting to that fine of a detail, you're really going to want to run the query tool. So this is kind of the basic level of what the import tool does. You give it a file, it tacks on the crash data. Kind of simple as that. So to do more advanced analysis, there are some boxes you can check here in step 2. One of the options that most people have requested was the ability to calculate an EEC. So EEC is the safety score we discussed in the query tool. That basically is the replacement for the critical rate factor. It's kind of the new metric that we're using to assess safety of a segment. So for these 5 or so segments we have here, you may want to get the EEC score for each one of them. So if you check this box, you're going to be faced with some more options to choose from. One option is whether or not you want to apply adjustment factors. So if you want to apply adjustment factors to your segments, you must have a field called AF, and it'll detect if it finds it or not and allow you to do this option. But if you have a field called AF, and in that field you have numbers that represent the adjustments from the base conditions, you can apply those as well. This would be important if when you import in a list of segments, some of them have wide shoulders, some of them have narrow shoulders, some of them have wide lanes, narrow lanes, different variations among a specific highway type. You don't want to be jumping from median with a median, without a median, interstates, rural 2 lanes, multi-lane. That you want to just adjust kind of at a finer level how different your segment is from the base condition SPF that we're going to be applying to it. Now remember, unlike the query tool, this is going to be all automated. It's going to run through the process. It's not going to stop every row and ask you questions to kind of fine-tune the analysis. It's going to say whatever the most predominant feature is of this segment, we're going to grab the closest SPF we can find. And if we can't find a matching SPF, we're going to say no recommended SPF, and we're going to plug in some very, very basic conservative SPF metrics, and you're not going to get really a very sophisticated analysis. So the adjustment factors are important if you know that your segments are varying greatly from the base conditions. Most people probably won't have to include those, or you may include those after you fine-tune the analysis a little better. I'm looking into the option to download all of the PDFs associated with each group. I think that's going to be something that's going to take a lot of time to process, and I want to make sure that's something that the cabinet really needs before we figure out how to implement that. So that's kind of a coming soon feature. So you have roadway segments, and those segments can be matched like we do in the query tool to HIS data, so roadway information data. Once we make that match, the first option is we can auto-detect the best SPF to use based on its geometry. So our Adair County from 0 to 1, well, that one's going to show up as a rural 2-lane road. It's actually it has a lot of vertical curve variation in there, but otherwise it's a pretty normal rural 2-lane type of facility. You could apply some adjustment factors there, but basically it's going to probably match it to the rural 2-lane SPF, and that's fine. So for each segment, it'll find the best SPF to match. When it gets down to the US 27, this is going to be an urban multi-lane divided or undivided, depending on which one's more predominant in that case. We looked at that example in the query tool, and one of the things we found is the first half mile is undivided, and then from 0.5 to about 1, it's divided, and it'll continue that way through mile marker 3. So if you match it with using this setting to auto detect, it's going to just pick the most predominant, which probably means it's going to pick the multi-lane divided facility, which would be okay, except you'd probably want to trim off that first half mile because it's very different. So that's one way to do this. Another way is to use the SPF selected below for all segments. Well, when you click on this, you'll be faced with a drop-down, and these are all of the SPFs that we have in the CDAT database currently available. So you can pick one of these manually, and then no matter what the roadway geometry tells us, we're just going to use this SPF. This is perfect if you have a list of segments and you know all those segments are similar roadway types. If they're all rural 2-lane, you can save the processing power of detecting the HIS element and just say, just use this. This is perfect for network screening. This is perfect for some type of analysis that you already know the segments, and you just want to run the analysis based on a given SPF. The last option, if you click on it, you can have each segment use a different SPF based on a new field called SPF ID, and then reference the ID in this table. So these are the available SPFs in the database, and each one has a unique ID. So you may have to do a little digging to get this to work, but if your first segment, like our example, is Adair County, it's going to probably be the ID number 1, which is rural 2-lane. You can put that same ID for the first 4 segments in our database. And the last one, you'll want to pick an urban multi-lane, either divided or undivided, depending on your segmentation. So the first way is auto detect by geometry. The second way is to use one SPF for everything. And then the last way is each record will use its own SPF, but we're going to reference it by an ID. And you can get those IDs right here. And as we continue to add more SPFs to this database, we'll just add them to this table and they'll show up. And again, we're paginated here, so you can kind of work through here and look at.
Are those headers clickable for sorting as well?
They aren't, but that's worth putting down as a note. I'll make those guys sortable. It's a pretty easy option to turn on. And then, yeah, you could sort it and look that way. We may eventually have a more interactive table where you can search and kind of look, or we can release this annually in our crash and rates report, and people can reference it that way. So does that make sense, Paul, kind of how we treat the SPF?
It does. And actually the complexity grows a whole lot as soon as you check that box to calculate the EACs.
Yes.
The tool seems very, very simple. The import tool does, until you add that additional process, and then it starts to mirror a whole lot more of the query tool with a lot of exceptions. Certainly.
True. And then the other thing you'll notice is you'll have, just like before, the option to choose severity. So if we're using auto detect, you'll want to pick a severity that matches. Again, we'll always get all of the CABCO data. So we'll get total number of Ks, As, Bs, Cs, and Os for each record. But when we're performing the safety analysis, you have to inform us which type of severity do you want to focus on. CABCO is kind of the default. That's what I would suggest for most analysis. That will use an SPF that's based on CABCO. If you are looking for specific more severe injuries, you might choose the CAB, Ka and B, or Ka. Now, obviously, when you start getting to smaller, to fewer injury types, your sample size is going to go down, which may affect your safety analysis. But picking the right severity type to match the model that you're using is a very important step. The CDAT will do its best to check to see that those things aren't in conflict, but you'll want to make sure if you're using this rural 2-lane Cabco, you'll want to make sure that this is set to Cabco. If you're using one of our CO SPFs, here's a rural multi-lane divided CO, you'll want to change this again to CO. We'll do our best to have this stuff automatically selected, but again, here's where the user really needs to kind of step in and say, I know what I'm doing a little bit here. I'm going to make sure these things match. I'm going to stick with our auto detect because I do have 2 different roadway types in the analysis, and I'm going to stick with Cabco. So those 2 things will kind of give us the best test run on this. I'm going to choose file. I'm going to choose test, and I'm going to say get crashes. So now with the EEC checkbox checked, it's going to take a little bit longer to do this analysis. I found that you can do 50 or 60 of these in a reasonable amount of time. When it gets to the point where someone's trying to do something statewide, we'll really have to do some stress testing to make sure this tool is built for that big of a analysis. I'd say if you're trying to do something on thousands and thousands of records, you got to just send it over to KTC, make it a KTSDS project. Which might be a good opportunity to plug that program real quick, Paul, if you'd like.
Absolutely, yeah. If you've got a data request that you'd like to make, we do have a project where if it doesn't require a ton of research and analysis, we can have one of the folks at KTC take a look at that for you. And you can visit ktsds.ktc.uky.edu. And we've got a simple web form there where you can let us know kind of what you're doing, and we can match you up with a subject matter expert or somebody at KTC to help you along with some of those requests. And we encourage you to take advantage of that. There's no cost to use that program. It's not something that you have to allocate any budget dollars to. It's already paid for. And we think it's a pretty good resource available to folks trying to do safety analysis.
Yeah, and again, if you have just a large request like that, there are much better tools to do the matching than to do CDAT, because CDAT's web-based and maybe a bit slower for thousands and thousands of matching. But we'll stress test it and we'll see kind of what those limits are. Well, I clicked through here and it didn't take 30 or 40 seconds to process these 5 segments. What it's done, just like before, it matched the Cabco data. So we have the crash counts. The other thing it did is it added a column called SPF type. And for each record, for each row, it finds the best SPF that matches based on the roadway geometrics. So for here, we looked at rural 2-lane and for the first 4 segments, and then urban multi-lane undivided for the last bit. We've calculated an EEC score for each one. We calculated a standard deviation. So again, if you remember from the query tool training, the EEC is our expected excess crashes, and then the SD, the standard deviation, kind of represents the plus or minus confidence interval that we have associated with that EEC. Last thing that's added is the LOSS score. And that, again, is talked in detail on the query tool training. So for more details on that, I'd recommend reviewing that course. This is kind of an abbreviated version of what's available in the data. If you click the download button, you get all of this data plus all the intermediate steps, including the SPF parameters and such. And then any notes related to the segmentation that may be there, the segmentation score, in which now here I'm thinking making a note. It might be worth putting the segmentation score on this table so that people can kind of at a high level see how good. Because I suspect our US 27 example in here is not a very very good one. Because of all the changing in geometry in that segment. So that's kind of the basic way to run the import tool. We can do the same thing using specifying the SPF. So since most of these segments are rural 2-lane, we could set this here to a rural 2-lane SPF, match the Cabco there. You want those two to stay in sync. And then you can choose the same file. Now, what this will do is it won't do a good job on that last segment, because that last segment is not a rural 2-lane road. So I'll just illustrate here how much the EEC will change. So it was a positive 500 something. See, that ran a lot faster because it didn't have to do the matching of the geometric. So here the EEC dropped down to 425, which is lower than it was before. I think in both cases, this is just an unhelpful EEC because the segmentation score is going to be really low anyway. So
difference of over 20%. So
yeah. I'd say for sure. So this, again, you wouldn't use this method that I chose here if you have varying highway types. Since I have varying highway types, I don't want to use the same SPF for all. So does that kind of make sense, Paul, on that route?
Yeah, it's good. Good overview, and I think probably one of the largest takeaways for the entire tool is that if you're batch processing, you're probably going to have to sit down and work it. It's not going to be something where you just spit out a CSV and immediately get the exact answer that you want. It will require analysis, but it's a good way of batching that analysis up. But you may need to visit the query tool as well and work between the two to really refine what you're feeding it to get the output that you desire the most.
Yeah. So I just off screen double checked that my test CSV file actually does have an SPF ID field. So because of that, I can use this last option here, where I've actually set the SPF ID very arbitrarily to the 5 segments in the database. In fact, one of them I set the SPF ID equal to 0, which won't match anything, just showing you that that's a possibility too. That just means that you didn't pick an SPF ID that we have available. I'm going to stick with Cabco. I'm going to go back and choose the file again and do get crashes. Now this should also run about as fast as the second version as well, because we're not matching to the roadway geometry. That's the part that can really take some time. There we go. It looks like it finished here. So now the first one I had the SPF ID equal to 0, which doesn't work because it's not 1. Then I put in a couple more that were obviously not related to that Kentucky 55, but just to show you that you can use different options there. The other thing that gets you into trouble here is if you start picking IDs that have different severity types. Well, you're only allowed to pick one severity type up top, so you're going to have to make sure those match as well, and that's pretty typical. You're not really going to run an analysis on a bunch of segments for cab or cabco or CO. Generally speaking, you want to do analysis using the same severity type throughout. So that'll probably be in the if you download the data in the error the notes field saying, hey, your severities don't match. So as you can see, there are various ways to use the import tool with respect to CMFs, but then there's not a whole lot of forensic analysis going on, segment score changing and that kind of thing. So it really is a high level batch way of computing data. And it would be something that you really are confident about your segments, and you know what you want to match them to and why. So this would probably be the second step to safety analysis if you're working on a series of projects. Paul, any thoughts or final questions here?
No, I think that that does a really good job of covering everything for me.
Excellent. Well, I think this concludes our import tool analysis. I appreciate everyone taking the time to listen in.
All right. Thank you.
Take care.